Hello everyone, welcome back to my channel, and today we are going to solve LeetCode question number 3, longest substring without repeating characters. So after watching this video, you would be very clear like how to solve sliding window questions. So in this question, it is extremely important for interviews and is one of the best problems to understand the sliding window technique. So by the So by the end of this video, you will understand, why brute force fails, how sliding window works, and how to code optimal order of n solution. So let's get started with it. So let's understand the question. So here we are given a string s, and our task is basically to find the length of the longest substring such that it contains no repeating characters and the characters must be continuous. For example, here we have A, B, C, A, B, C, B, B. So the longest substring here with non-repeating characters and is continuous is A, B, and C. So the output is 3. Here next in example 2 we can see is B, 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 B. So the output is 1 with the length 1. So substrings, not subsequences, and no duplicates are allowed out here. So if we would have used brute force approach here, it would be basically generating, all substrings and check each substring for unique characters. But it would take order of n squared time in worst cases. So it's too slow. So we need to think something else out of the box. So to optimize this, what we'll do is we will use a sliding window approach here. What we'll do is we'll maintain a mid window from left to right and expand our right to include new characters. And if a character repeats, we will move our left pointer forward and we'll always track the maximum window size out there. And so to do this efficiently, we need to remember the last index of each character, right? So this is basically the idea we would that we would code. So let's just code and understand it much better. So here first we will create a hash of 256 size to basically store the last index. Here 256 because ASCII characters can be up to 256 values, and for each index we have to store the last position where the character is up where the character appeared, right? So that's why we would use hash. Now what we'll do is we will loop out it for I is equals to 0, I is less than 256, and I plus plus. What we'll do is we'll do hash of I equals to minus. So here we have initialized with -1, basically to mean that character has not appeared right now. So now any character where character is not appeared right now, even 1. So that's why we have initialized it to -1. Next, what we will do is we will basically create pointers out here. One for the window out there, left for the starting of the window, right for the ending of the window, and we will create a variable maximum length to basically store the answer. So when left is equals to 0, right is equals to 0, and max length is equals to 0. Then what we'll do is we will loop out it until our right is less than our string's length. As we will basically move our right forward one character at a time, that's why. So here we'll put up a condition out here that if our hash of s of right is greater or equal to our left, then what we'll do is we will move our left pointer like move our left pointer to hash of s of right plus 1. So what we did here is basically we'd check that if the current characters has appeared before and it lies inside the current window, that particular window, then what we'll do, we will move our left pointer just after its previous position. So what we'll do, so this would basically remove the duplicate from our window. So we would put out a condition here that if our hash of s of right is not equal to -1. So what we will do is we will basically put out another condition that if our hash of s of right is greater or equal to left, we'll just move our left pointer ahead to the next position of left is equals to hash of s of right plus 1. So we have just checked here that if our character has appeared before and it lies in that particular current window, what we'll do is we will move our left pointer just to the previous position, just after its previous position. So this would basically remove the duplicate from our window, nothing else. Next, what we will do is like we will create a variable length, and we will find the length of the current window, right minus left plus 1, and we will find the max length, then max length equal to max of max length and our length. So here we calculated the current window size and then updated and the update, and then we have updated our max length to that. And then what we'll do is we will update, we also have to update our last seen index, right? So it is not -1. So what we'll do, s of right would be equal to right, and we'll just move our right pointer ahead, right? So here we have stored the latest index of the current character, then we have moved the right pointer out there. So now just let's run. Okay, first we will return maximum length. Now just run and check it out here. Yes. So here the time complexity is order of n and space complexity is also order of 1, as we have fixed 256 size array, right? So this is one of the most important sliding window problems. So if you understand this sliding window hashing to pointer, it would be very easy to solve more such questions out there. So if you want more questions like this, you just like this video, or if you want any specific question or a different version of this questions, you can just comment it down. And yes, thank you, and subscribe for more lead code questions. Thank you.